Welcome to the first ever Qubit Tensor Labs Live. We're super excited to be here. Super excited to have you all here. We're not going to be checking all of the chats as we're going with this, but would welcome you guys, on Riverside Chat or anywhere else to post things up. And if we don't see them while we're going, we can always hit them up later. All right. So I came from the corporate world. And like my entire career, I always wanted to do stuff like this where you just like have random meetings where the developers can say whatever they're working on and whatever points of view they have with like users and investors and stuff like that. But like the lawyers always say, you can't possibly do that because you're going to make a bunch of forward-looking statements and you're going to get sued and it's going to be terrible. So in an abundance of caution, I told Grok to cover my ass. And that's what Grok told me. I did review it to make sure that there was no references to Mecha Hitler or, anything like that. But I'll give you my read on this, which is basically these are all ideas. We're going to be talking about a lot of stuff that's sort of like the way we see it right now. And a lot of that stuff is going to turn out to be right. And a lot of that stuff's going to turn out to be wrong. And so our aim, if everything works right, is to do these things pretty often, every couple of weeks maybe. And, our ideas might change over time. It's definitely not intended to be investment or legal advice. So, you guys can listen and do whatever you guys want to do with the information, but we're not, if we make any statements about any kind of like alpha price or anything like that, we're not qualified to say those types of things. So don't listen to us. And we would appreciate it if you didn't weaponize this material or use it out of context. I'm going to be including a bunch of screen grabs from stuff that you guys have said in the community throughout, and I hope I'm not weaponizing them or using them out of context either. Yes, but we're here to be sharing information, and if you're still here, we assume you agree to all this. So with that said, let's roll. So I wanted to first say, on novelty search, I talked about, our first beginnings with 63 being like dipping our toes in the water, and we wanted to dive in head first. And I sort of had this like grand vision of like, we're going to be perfectly diving swiftly into the whole qubit ecosystem, but it kind of felt a little bit more like this because we, on one hand, we got sort of like all of this praise for, a pretty solid novelty search. But then on the other hand, a lot of people were sort of surprised by big things. The charts didn't necessarily, show to the moon green bars and stuff like that. And so we sort of learned some lessons. And the biggest lesson I learned is avoid big surprises for people. And so the aim of this is really to like, for those that want to know stuff, we want to give little incremental updates as we go. As we continue to evolve our thinking, we want to bring you with us. That way we can have kind of communication on this as we go. The other thing that I am worried about, honestly, is just to understand like the mindset of the DTAU investor and to understand if these things sort of become one of these weird like sell the news kind of things. We're hoping that this actually doesn't cause that type of behavior, but instead by putting information out consistently, we're avoiding that type of behavior. But yeah, I don't remember who posted this up or where, but I totally agree. It seems almost unintuitive. It seems almost unintuitive when you share good news and markets crash, right? So okay, so the agenda for today is we're going to start with like some really tactical stuff, just more like tech support type topic. We're going to talk about generation times, stability of 63. We recently released the promised incentive pool, so we want to talk a little bit about that in Grafana. We also want to spend a little bit of time talking about the stuff that we're working on, the sort of upcoming stuff. And so that includes, I'll give you a little run through of the Open Quantum UI, which is a mock, and I'll make sure that we tell you what's real and what's not real kind of as we're going there. As well as like an overall progress check-in. Also, the HTAB solution got solved, so that's big news. So we're going to have Bongo Cat Feynman will take us through kind of what that solution looked like, and just a little bit about like the broader market of miners and how they all reacted to that. And a quick update on the next challenge, which is a Shores-oriented challenge. And then we're going to focus on some things I probably should have called that strategy, but it's more like community. So all throughout the last 2 weeks since novelty search, like my whole team has been sending me like screenshots of what y'all are saying in different parts of the community, which is like spread out across lots of different tools. And so, the big sort of messages that we've heard about in the community recently have been sort of like, what is the value of innovation in a world where 48 exists for compute? And what is the interplay between 48 and 63? So we'll spend some time talking about that too. Sounds good. Let's dig in. So, tech support. First, we're going to talk about generation times, and you guys all know, Bongo Cat Feynman, Will. So, Will, I'll let you talk about kind of our first quantum approach at speeding up peak circuits.
Yeah, cool. So I guess my slide remote disconnected, so I might have to ask you to advance through the slides.
That's cool. I got you.
Yeah, all right. Anyway, so yeah, so I'm sure everyone here knows by now, the peak circuit generation has been slow, and so top priority for us has been to speed it up. And so we got in touch with one of the original authors from the peak circuits paper, Yushen Zhang. And so it turned out that he was, kind of also noticing this and working on some other stuff to really extend his sort of frameworks. We got in touch with him. We got I guess a bit of insider information on his newer work, I guess. And can you advance, please?
Yeah.
Yeah, and so like this is kind of I guess an abstract representation of one aspect of his work that he was very generous to share with us. So the idea is that like currently the peak circuit generation generates this big block of a circuit, right? And the idea is to break it up into smaller pieces that can each be that are each themselves sort of like mini peak circuits, and then stitch it all together into one big one, right? And so there was a lot of optimism that we had that this would work out, and it was showing some great numbers. But for quantum reasons, I don't know if people have questions, we can get into exactly the quantumness. But for quantum reasons, it was turning out to be too easy, right? If you can advance,
Yeah.
please. Yeah, so like this sort of stitching approach to making smaller peak circuits and putting them together would have yielded some huge speed up that's we have conservatively 10x, but it's possible it could have been even more, right? And that would have been great for the subnet. Basically the day before we were planning to launch it, we found this vulnerability that turned out to make it really easy to simulate, and so it just wasn't really feasible.
Yeah. So if I were to play back kind of my slightly less quantum, slightly less deep version, originally we would generate the entire circuit as one thing. And because it was generated as one thing, the random entanglement that we had would be massive. It could scale all the way across the width of the circuit. But in this new world where you're generating these smaller circuits really efficiently and stitching them together, you end up having like this really localized entanglement, which then it does create a problem that looks really similar to the original problems. But because the entanglement is sort of localized, it ends up being really simulatable, right?
Yeah, that's right. Yeah, and so I guess just to finish out the slide, you can go one more. So like we're still sort of exploring this idea. There's still the possibility that we could work towards some place where it's still pretty hard to solve, but we haven't reached it yet. So it's still sort of an ongoing thing. And then Ryan can talk about what we actually.
Yeah. So after this, quantum approach we found this vulnerability in it and decided it really wasn't worth launching it until we understood how to work around that vulnerability. The quantum guys went to the computer science guys and said, "Hey, how much better can you guys make this without a substantially different quantum approach?" So, short shot, Ryan, you want to talk about it?
Yeah, so we really took a look at kind of our original generation method and looked at ways on how we could, speed up transfer and optimize where we transfer memory between CPU and GPU. We also found that even, reducing the floating point size down from, complex 128 to 64 actually kept enough precision that allowed us to still generate circuits and find the peaking. And then also, one thing that we noticed is that there's there's a percentage of what you call, I guess, lucky seeds. There's a percentage of what you call unlucky seeds, and there's like in the middle where things are sort of averaged. And what we try to do is avoid generating circuits based upon those unlucky seeds, and that way we could improve the speed of the generation of that circuit. And then there's also things that we haven't exactly pulled the trigger on yet, to even optimize more. seeing if we could get miners to use multi-GPU. You know, one of the big challenges that, I'll talk a little bit about later is that, varying hardware between different validators could uh, uh, produce different results and in different speeds. And then, how do we kind of balance the weights between all of the validators for the miners out there? So
Nice.
I think what we have does great up to 39 qubits, and we're trying to get past that as soon as possible in order to keep the challenge going, as opposed to kind of topping out at a certain value.
Yeah, awesome. Super cool. Also, by the way, which AI made that Qbtll GPU icon? That's hilarious.
Yeah, that's a Grok Imagine, right? Yeah.
Okay. Yeah. I feel like every time I try to get AI to do words, it still like completely messes up.
It
All
kind of
right.
it actually, in all honesty, it did that one by accident, and I'm like, I don't know how it picked up on that term and like how it even
No
came out with
way.
it, but it did it on its own, and I'm like, all right, perfect. We'll just have to roll with it. So
The Qbitties have taken over Grok. Awesome. So, hey, we'll have you keep with us and kind of talking through stability, because 63 is forever going to be in this mode of, continuing to like fend off new exploits. The community keeps doing better, which makes things harder. So you want to take us through just a little bit of the stability side of things?
yeah, I mean, it's our team is new to BitTensor. There's a lot of challenges, a lot of new learning. It's totally different from other full stack startups or enterprise application development, and working through challenges of being decentralized or varying validator hardware or what the validators want to share with us and what they're willing to run. And, also on top of that is defensive programming. We're being attacked and exploited in different ways than, kind of the standard suite of exploits
Totally.
and things that come out for the cloud. So, learning to be better at that and to provide more stability from that perspective, and then also using what we've learned on 63 and apply it to 48 and open quantum, and that we could come out of the gate having a more stable and robust and resilient system.
Yeah, awesome. And one of the things that maybe I'll like add into this is like just an outsider observation is that, if you think about like how fast people move in the academic world, things move arguably really slow. In the like large corporate America world where I spend a lot of my time, things move like a little faster, but still relatively like slow. Startup where I've been in the last, 3 years moves fast. BitTensor moves like breakneck fast. It's insane. Like, I mean, there's so many people doing so much, moving so fast. Every day, new ideas are coming out. People like miners are weirdly working together. Like I didn't expect that. I thought they'd be like competing against each other. Like, but
Right.
you had to move fast in BitTensor, which has been a lot to like, get used to.
It's good and bad. It's like, you get a lot of good feedback from the community, about new ideas and kind of new paths to go down, but at the same time, it's, there's a lot of expectation, I guess, and being able to keep things stable and perform and keep continually producing challenges, and it's a lot to manage.
Oh man. Yeah, by the way, Qubit Tummy just dropped a blast from the past. They said all your qubits are belong to us. What a nice ancient
Nice.
relic of a quote. All right, tech support. I did just want to address incentive pool. So like a number of weeks ago, we said we were going to start holding back an incentive pool. We hadn't started keeping the incentive pool until just yesterday or a couple days ago. We finally started actually collecting that and carving that off. Yeah, if anybody has any questions on that, we can talk about that more offline. But I think right now, the way that 63 was originally oriented, it incentivized people to get to the right answer, but not to disclose how they got to the right answer. And one of the big things you'll hear about in sort of the strategy section of this is like it's going to become increasingly important that people are sharing how they're getting to the right answer. And in fact, there will be sort of some, structural changes over time to make that just more natively built in. Grafana also wanted to hit on, and Ryan, feel free to jump in if you have other stuff to add. But we're super excited about it. I took some fresh screenshots this morning. Things are looking pretty solid. Whether you're looking at validator health or circuit generation or sort of like minor weight alignment, like in my opinion, things are looking pretty healthy. Also, just as like an interesting thing, you can see people are definitely reliably requesting 39 qubit peaked circuits now, which is pretty insane. We haven't released this to the public yet, and the key reason for that is uh, we sort of have seen how people go deep on the data right away, and we want to make sure that all of the data that we're reporting is as accurate as possible before we get the scrutiny of the public world on it. Also, we do have like a little issue that we're trying to figure out where the if a validator restarts, there's like a couple hour gap in data, and yeah, that feels sort of like too much to be gapping out at.
Yeah, open telemetry could be a little bit finicky, but then there's the layer of Griffon on top of it. We're using this to provide the visualization. So there's a couple little bugs and issues that we're gonna have to track down before we feel completely comfortable that it should be released to the public.
Totally. Yeah. And when we do release that, like, so we've got our front end dev with a branch that has the link to it right off of the Qubit Tensor Labs website. And he's just waiting to ship it as soon as SureShot gives the green light. So yeah, we'll see when we feel good enough about it. Okay. Jumping into R&D, Open Quantum UI. Yeah, this is okay. This is my favorite part. Hold on, let's see how hard this is to actually do. Oh, that was easy. Okay, cool. Yeah, so I'm going to share something with you. Right now, we have like multiple different streams going on Open Quantum. There's like the subnet development. There's the traditional centralized full stack development APIs and database and the connectivity of those things. There's front end development to spec out what the user interface is and implement it. And all of those pieces like need to be connected. So what I'm showing you guys right now is not a fully working system. This is the front end, which needs to be connected into those other ends. But thought we'd show early because, seeing something really sort of like codifies what it is. So Open Quantum is going to be the website that users go to, that BitTensor users go to. You can see that on the website, you can just click create a job. You can go in and pick one of the QPU providers that is available, pick one of the backends that is available. You can go in and just grab a CHASM file, which is like the quantum circuit to be executed. In this case, this is a VQE simulation, collect a little bit of metadata from people, and each quantum computer will have different configuration parameters that you can set for it. You can submit the job. You can see that we're going to actually provide free access as long as people are comfortable submitting their jobs through this public network, meaning that it goes completely through the BitTensor ecosystem. We also will include, private plans that will allow people to sort of do it in a more centralized way, but avoids their IP being broadcast to miners all over the place. They can go ahead and submit their job, and then the jobs are tracked in the website. They can cancel them, they can use them, they can download the results from them, etc. The one other thing that I will call out is that that's cool. It's like neat eye candy and stuff like that, and it tells you kind of what we do, but it is probably not the way that anybody's ever really going to use it. Everybody's just going to pip install an SDK and integrate it into the frameworks that they're working with. So like today, people develop software, they run it on simulators, they'll just load in their license keys, which they'll have through the system, and just run the code. The other thing that I do want to call out, because it's going to be super relevant later, is that for the insiders who are wanting to support innovation, you can actually add a wallet, and we'll go through and validate your wallet and add it to your list of linked wallets. And whether you're staking on 63 or 48, you'll actually get this. Well, and this is, again, what our intention is right now. I think this one's pretty solid, but again, everything's kind of fluid. But the intention is to essentially have a dividend in the form of credits. So if people stake on 63 and support innovation, or to a different extent, if they stake on 48 to support compute, they end up getting credits on a monthly basis that they can then apply to either switch from public to private, or to jump in line to reduce wait times, or to increase the number of shots, etc. So in a way, you're sort of giving the community to either buy credits with a credit card on the fly, or to stake. And depending on the duration that people have staked for, they'll get those credits. Cool. So maybe that's enough of that for now. But yeah, we're super excited about it. Which parts of those features end up in the initial launch, which parts of the features end up in subsequent launches is a little bit up in the air. But I'm seeing these hearts here. I don't know where they're coming from because we don't use this platform often, but I appreciate the love. Cool. So other than that, Ryan, I was thinking we maybe just have like a quick little progress check-in. I know this is like a giant system, but what parts are you feeling like are sort of like on track? What's off track? How are you feeling about things?
Yeah, I mean, we're uh, pushing hard on trying to get everything completed here, and I think we made a lot of progress on uh the bit tensor side of things in terms of the validator, how it's communicating with an API in order to feed it jobs off Open Quantum. We're doing great on the UI mockups and what we think the user experience should be. We're finishing up a lot of database design and Open Quantum specific design tasks, and then going to be hitting hard into development over the next couple of weeks here. So
Yeah, sounds good. And one of the things I've been like, so 63 was super interesting to watch that come together to just learn like what a subnet is. But 48's been really interesting because it's like you got to do all that. But not only that, but like, we need validators running really thin web servers and running REST APIs. And we need to have a full stack Open Quantum, which is like, front end APIs, back end. And we need to have the Python SDKs to connect into the quantum frameworks. So it's really like, it's not like it's not like even like twice as hard. It's like, 4 times as hard. But I've been super impressed with what you and the team have been doing around like documenting artifacts, unit testing, bringing in a lot of the like stuff to ensure stability because that's going to be really important as we go with this. All right. Moving on then to HDAB. Will, I was super excited about the publication that you collaborated with a miner on here. I'll, again, tell me when you want me to progress slides, but I'll hand it over to you to chat about
Sure.
this.
Yeah. So it ended up being a very cool solution that I'll talk about on the next slide. But I guess before getting into it, I was seeing some uh, a few people on the various Discord channels talking about how the solution gets decided, and whether this should be done in sort of a decentralized way. That I just wanted to address here, right? So this is kind of an awkward problem, right? Because we are dealing with quantum stuff, but there's really not any sort of built-in assurance that there are a lot of proper quantum people who would be able to go through and sort of validate whether a solution is worth sort of breaking the pool out to or not. So I don't mean to call out tensorized. I don't know if you're here or not specifically, but just sort of to highlight the general sentiment about how we go and choose which the best solution is. Currently, the solution, which I think is really the only feasible solution right now, is that miners would go and sort of DM their solutions to us with a full technical explanation. This seems to be the most reliable solution, at least right now. We may revisit this in the future. Not a super hard promise or anything. Maybe once people have gotten more up to speed with all the quantumness that goes on in the background with all these problems. But yeah, for now, I think the only real workable solution is to have this sort of DM structure.
Totally. Yeah, and also I do think that well, and we'll talk about this, I guess, in the like next slides when we talk a little bit more about 63 strategy. I mean, 63 will essentially move to a place where what is being submitted by the miners is IP that is verifiable and testable and rewardable, and so it will become, I think, a lot less I don't know, a less like up to opinion, I guess, in terms of like who succeeds or not. But in this case, I did feel that there really was a clear winner. We had one miner who I'm gonna guess is like probably from the quantum space and not originally from the bit tensor space, just based on what they had submitted. Because it was sort of like a very comprehensive and detailed and well thought through uh, set of work.
Right, exactly. And so like in like the golden case, right, the golden path here is that we have something that someone comes up with here that's like publishable, right? And if it's like completely new research, something completely new that's like worth trying to publish something on, then we want something that's like a full explanation, that's going to have to come out at some point, and so like it has to be very technical, right? It has to be totally paper worthy. And that's kind of the standard that we want to think about here. And so there's sort of like a dual version of this, the entire problem of operating on the subnet itself, which is like we have to be able to see this and verify whether whether it is publishable. So like at some point, everything has to pass through us because we're kind of the ones that would in principle make this wider publishing happen. That makes
Yep.
sense.
Yeah. So take us through the solution that won.
Yeah. Cool. So so this was the winning solution is based around this thing called polypropagation. We put out a technical paper on exactly what that is. You can advance, please. So like I guess this is sort of a continuation of this idea of like who decides which wins. Again, I don't mean to call out Tensorite specifically, but this was kind of the most articulate version of this viewpoint, right? So it looked from sort of a broad survey of what was going on in the subnet that there were sort of two solutions. There was this one, polypropagation, which is only one miner came up with and ended up being the winning one. But it seemed like most other people were doing deobfuscation, which is not a real technical term, but it's what people are calling it, which is where you take the H-type circuit that they get and you convert it back to sort of the original Clifford form, and that allows you to do fast simulation to get the stabilizers out quickly. So anyway, just to give a little bit about polypropagation, right? The idea is to take a polystring, which I'm calling P here, and go through and preserve this particular invariant. And it's like the term that people usually talk about is massaging equations, right? So you massage the equation enough until you get to a form where things are workable. So the idea here is to massage this leftmost equation on the top left of this math here. If we have a circuit C and a polystring P, then what we can do is insert identities C dagger C and C dagger C on both sides, and that ends up giving you sort of another polystring, the CP C dagger here, that represents the stabilizer of the output circuit, or of the output state of the circuit. And the thing that allows polypropagation to work is this deeper understanding of what goes on when you try to multiply polystrings with non-Clifford gates, with this particular flavor of non-Clifford gates. And again, there's a lot more detail in the technical document. I strongly urge people to look at this if they're still thinking about the question of polypropagation versus deobfuscation. And so I guess what I want to say here at the end of the day is that I kind of resist the idea of making a hard rubric because there's lots of variance in what solutions can look like. But broadly, I'm going to say that solutions, in order to win, should get points for effectiveness, right? There was some note about deobfuscation being pretty fast. When we were testing the winning solution, we found that it was actually faster than at least what's being claimed here. There were not a lot of people who submitted thorough solutions, that is to say, like source code plus a full technical write-up like the winning solution did. But we found that polypropagation was actually a lot faster than several seconds. It was sub-seconds for 50 qubits. So we found that it was more effective. Let's see. The other point.
That's crazy, man. Sub-second for 50 qubits.
Yeah, so it was pretty amazing. So the other thing that solutions should get points for is sort of the depth of the solution, right? How well they interact with, like how deep they go in terms of sort of what math they're interacting with or what physics they're interacting with. Sort of the depth of understanding that's required to go into the solution. And the point is the elegance of the solution. Deobfuscation, right? There's this idea of in one of the deobfuscation solutions that we found, which is to go and basically look at all of the gates, maybe do some merging in a circuit, and then basically just test all the available Clifford gates in the space to see like which one sort of fits in. And so to me that's not very elegant, because what happens if we go up to 3 Clifford gate or 3 qubit gates in the obfuscated circuit, right? So and this is an important point because the number of Clifford gates grows double exponentially, approximately, in the number of qubits actually. So the space gets very combinatorially large, and so that's sort of the main, I guess, obstacle to the elegance of deobfuscation that I want to note. And then
Yeah.
finally, I think it's worth giving solutions more points for sort of the uniqueness of the idea. There was only one miner who came up with the idea of applying Pauli propagation to this problem, and I think that should be rewarded. It's a reward for sort of not following well-trodden paths and actually getting to a spot where you can actually do meaningful innovation. Yeah,
Hey,
and then
by the
so
way, Will.
yeah.
Oh no, no worries. I think everything you said there was right. I think the one thing I would say, like, and it didn't apply to this problem, but like, like universality would be something we should look at also. So like in this case, this solution for sure is very like specific to this type of circuit, and like because the effectiveness and the depth and the elegance and the uniqueness are so high, the fact that like it's not a universal solution really doesn't hold it back because it gets such high marks in those other areas. But definitely in the long run, looking for like more universal things will be key too.
Yeah, that is true. I shied away from putting universality on this list as like an actual point. Like I think there are sort of slim chances that you could find something that's really universal. But yeah,
Yeah.
I guess I would tend to also lump that in with like elegance. But yeah, that's a good point.
Yeah, fair point. Also, the other thing I will share is I think I fixed your remote control through some trickery in the background.
Cool.
You can. So when you get to your next slides, you might be good. And we are a little bit tight on time. I don't want to go too much longer than like 45 minutes because I appreciate that there's limited time that everybody has. So let's hit the next challenge. I'll give a couple words on it, and then I'll have you take us through it, but kind of in the abridged way because people have a lot more time to focus on this one when we
Yeah,
launch it.
sorry. I tend to talk a lot.
No, 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 no. I don't want to discourage that at all. But what I'll say about the next challenge, before I have Will give us a little bit of a overview technically on it, is this one has been really fun because we actually had working code for this a really long time ago. But before handing the code to be integrated into the subnet, we said, hey, we need to take some time and look at this like we're a hacker and not like we're a quantum scientist, and basically say like what side doors, back doors, what non-quantum ways could we kind of try to attack this. And we found like a really cool attack vector, which I'm not going to say because I don't want to plant the seed in people's minds. So then we went back, worked around that, fixed it, tried again, found a totally different attack vector, went through, fixed that, came back again. And so we have something now that our white hat hackers are comfortable with. And so we just handed the code from the quantum team to the BitTensor team to start integrating it. And Will, if you want to give us just, 2 or 3 minutes on it, that'd be great.
Sure. Yeah. I can advance the slide now. Okay. All right. Yeah. So the next challenge is all around doing one iteration of this well-known Shor's algorithm, right? It's the algorithm itself is meant to factorize some number that I'll call it n. That's a pseudoprime. That's the multiplication of two large prime numbers, right? And it's all based around a bit of number theory that says that there's some r, right, such that for some a, you can raise a to the power of r and have it be equivalent to 1 modulo n, right? And you can use this r value to generate these two, to find the two pseudoprimes. Um, I guess in terms of the actual circuit that's actually run, it looks something sort of the naive picture or implementation of Shor's looks like this, right? So you have a couple registers, you do some operations that look like applying this modular multiplication in sort of in a quantum way. And then you have to apply some broader transformation called the inverse quantum Fourier transform to produce what ends up looking like peaks in the output of the circuit. And the reason this algorithm works, oh, that got messed up, is that is because the spacing between the peaks and the output of the circuit is proportional to, in some form, or like it encodes this R value of this operation. And so, I mean, that's the high level overview. Shor's is pretty well documented at this point. So if people are more interested, they can do some searching on their own. or they can just wait for the upcoming technical description that we have for this challenge. It will be out soon. It'll be out in advance of when we actually release the challenge itself. Yeah, anyway, that's the, I guess, quick version
Yeah,
of this.
totally. And the cool thing about this is like people will be doing shores, but oh, I just saw somebody say stop this podcast. I don't know if that's because they're worried we're going to break encryption or if our like alpha is tanking in the background. I don't know. Don't look. I'm not going to look. We'll keep rolling.
All right.
But the cool thing is that like people don't need to know how to do shores. The validators are going to generate shores circuits, which is like one of the important steps in it. And then if you can find this R value and you submit back a sample set that like shows us that it was faithfully executed, then you win. So in a way it allows us to like test the complicated execution of shores without putting the onus on the miners to become expert in shores algorithm. Yeah, really cool. Okay, so we'll jump right into this other stuff, which is sort of probably like the stuff people are the most eager to hear, which is sort of around the value of innovation and revenue interplay between 48 and 63. And so, what I will say is, I just grabbed a couple random things that came in from different people on the team, screen grabbing this stuff and shooting it my way. This was kind of exciting. People like, what was it? If you had to only invest in one DTAO subnet for a long time, which one would it be? I was pretty blown away that Quantum stood out above these other ones. So thank you all for helping us with that. I see people talk about like, hey, the activity of miners and thinking about that, or what we post and getting really excited about that stuff. And like, I guess what I would say about all this stuff is like, all of that stuff to me feels very like instantaneous, and like that sentiment's going to go up and that sentiment's going to go down, right? Like we'll probably say something stupid. I don't know, maybe we already did on this podcast. We'll say things that are smart. We're going to learn, we're going to iterate. But what I'm really excited about is like the real value, not like sort of the speculative value. And so like I grabbed this post from somebody named Kai, which was also in this database we were collecting. And I saw a couple things that I was really excited that were noticed. One is that we're cautious about overpromising. So that definitely comes from the fact that like we come from large business where we want to make sure that we can really deliver on something before we promise. I also was really excited about seeing that people see that quantum is sort of stuck in this intellectual elitist space, and that really there's tremendous value in taking that innovation and making it accessible to people. And that people were seeing that subnet 63 is the innovator and subnet 48 is the quantum resource, and that the users of those things are actually like a lot different. But, this call out was right that we need to provide more of a roadmap for how that all is being productized. I also liked this one. I saw this one personally. I think I screen grabbed it. There was this idea that we need to make 63 easy enough for quantum researchers to plug into it and get started, that we want gigabrains from the labs to be competing for money. Also, I like that because it's like US dollars and not Tau, which I think is really right on. I bet Scott Aronson wants to play. I was thinking probably Scott Aronson doesn't, but probably like his PhD students do. So that's maybe more of the play for it, is to say, can we actually get those type of people on? And we could even build a front end that lets them sign up and try things and then run on compute. But 48 can also be that compute. And then this, I think, was like a shout out to Ridges being awesome for removing crypto from mining, which I also thought was a really insightful thing that's in alignment with what we are also thinking about. And so if you think about like, I think a lot of people have made this comparison that quantum computes is essentially the quantum chutes. I do want people to start seeing quantum innovate as working towards becoming the quantum ridges. And what you sort of might take away from something like that is ridges has very much focused on allowing outsiders in. And we've been really impressed with what the BitTensor community has been able to do, but like we do want to get quantum people into this space also. And like it is a lot to take in for somebody from the outside. So we want to abstract away a lot of the complexities of BitTensor. We want to talk about things in US dollars when we're talking about these sort of innovation challenges and awards. And we need to get miners to providing their answers as open source, as opposed to proof that they solved the problem without, requiring them to get to how they solved the problem. We also want to get to problems that are quantum meaningful. So right now we started with a problem set that was focused on getting the BitTensor community more in the weeds of quantum, which is great. Phase 2 is about scaling quantum simulation up with broader sets of circuits. And that still is a very valuable and meaningful problem to the market. But there's lots of other, types of problems like quantum error correction. If we can make that a little bit better, it's going to radically advance how we get to large scale quantum computers that cure cancer. If we can develop more efficient quantum algorithms, like right now, the way that we do a lot of things, like especially some of the optimization problems that we have, people aren't even sure if those are going to have like an exponential advantage. There are some where people are highly confident it will. But if we can get to actually developing more efficient quantum algorithms and rewarding those on the platform, that's going to be of tremendous value. If we can start doing things like challenging people to push the envelope with quantum cryptography so that we can understand what is the current state of the art that people can do with quantum algorithms, that's going to be highly valuable. So starting to expand into more meaningful problems, is definitely the roadmap there. And then building from ridges, one of our missions isn't just going to be getting, highly qualified people in, but it's also starting to attract pedigree. Like one of the things I hate about quantum is you need pedigree, but like it's actually just a truth about the market. And so, yeah, that question about, can you get the Seth Lloyds, the Scott Aronsons? It's like, I don't know if you can, but like if you get their PhD students or their labs in here working on this stuff, like you've crushed it. Also, can we incentivize quantum experts to eventually moderate those problems? So don't just put it on the small set of people that we have in our company, but actually expand out to other people and challenge them to bring problems into that network. And so, yeah, like I hope that really articulates, like, I mean, on Novelty Search, we talked about like this world that I want my grandkids to grow up in where like cancer has been solved, cars just drive forever and are hardly ever have to be charged with low impact on the earth. The goods that are needed get to the people. Like in order for all of that to be true, we can't just provide access to compute. We need to be providing innovation to make the compute actually solve those problems and to improve the trajectory that the compute is on. And so, like, there should be no question about the value of innovation. I do think certain types of investors will be attracted to innovation, and certain types of investors will be attracted to execution and operation. And I think there's room for both of those. Okay, so then talking a little bit about the interplays, we kind of talked about it. Well, actually, the slide's sort of weirdly out of place now that I think about it. But we already sort of talked about some of the interplay, but we'll talk about a little bit more. But just to codify that roadmap, provable accuracy is where we are today. Synthesized problems is where we're going, which you can imagine becoming sort of one of the challenge areas that we ask for continuous innovation on, is being able to execute broadly generated synthesized problems. But where we definitely want to go is to quantum innovation, period. And that's beyond just execution. That's other very important problems that are going to accelerate quantum. It's open source, not just getting the answer. It's rewarding innovation with US dollars and not just tau or not just alpha. And it's about getting outsiders in. And so when we look at that ecosystem together and we say, well, how do they interplay? Well, imagine a world where open quantum, built on quantum compute, subnet 48, attracts essentially every user that does quantum computing in the world because they immediately have access to free computers. We generate a little bit of revenue. That's cool. A lot of people like that. And we do that by letting them execute privately, jump in line, or removing some of the limitations to the jobs that we submit through the sale of credits, which again, you can subsidize, and we incentivize that staking. We incentivize staking on 63 and 48 by generating credits based on how much you stake. I also saw some questions about like, is there a market for reselling credits? Honestly, hadn't talked about that. But what we had talked about is making these credits like specifically useful in certain ways, which might mean that you have to use them sooner or they get used sort of ahead of credits that you pay for, things like that. So there's some thinking to do on that. I appreciate the Discord on it. But if we have all those eyeballs and we have essentially everybody in quantum coming to this openquantum.com in order to execute their circuits, what better place would there be to promote innovation awards to sort of expose people to the fact that, hey, yeah, you have this quantum computer time. If you want to use that free quantum computer time to solve these meaningful quantum problems, there's cash available for you. And we pay you in USDs. and we publish what we've paid out on Open Quantum to make sure that it's all transparent and above board and real time. And while BitTensor is the engine on this, these guys just, look at the car, right? And they see, a beautiful shiny car that they get to drive for free. And when an innovation award is on one of these simulation tasks, right? How do we execute quantum circuits generically better? Those innovations actually get to be deployed as backends, right? You saw in the demo that you could pick which quantum computer or simulation backend you wanted to run on. We can kind of continuously update the image for that, that backend based on who's winning on 63. And all those other innovations, there's the opportunity to launch those innovations as hosted services directly on Open Quantum. And so, the near-term value proposition is free quantum computing, right? As soon as we have created undescribable value to a very needy market that is, rather large, and also everybody knows everybody, so we should be able to spread like wildfire. Once we capture a share of that market, we can use that market to pull everybody into these innovation challenges and make those thrive. And also it gives us a platform to broadcast the innovations as they happen too. And so you can see, like, in my mind, this has always looked like, two different parts of the same solution. And with our original naive thinking of single subnet, we essentially had to stop one of these threads in order to do the other. And, while I appreciate that, the announcement at Novelty Search was too big of an announcement to make on a forum like Novelty Search now, I think the learning that we have gone through to understand that this has to be two subnets in the long term, and that these two subnets are going to make each other thrive. And also, by the way, they could independently succeed. We just think that the future is super bright and super exciting. So with that, we sort of opened with this. I kind of felt like this after Novelty Search. I haven't looked at Discord and I haven't looked at the charts. So I have no idea, but I'm hoping that we feel a little bit more like this. We didn't quite belly flop, but we'll hopefully continue to learn and evolve and keep this series going. So with that, I think we will sign off. Okay. Thank you, everybody. And thank you, Shoreshot, aka Ryan, and Bongo Cat Feynman, aka Will.
Cool. Thanks, everyone.
Thanks, everyone. Bye.